You should have taken notes over changes, whether they are physical changes or chemical changes. And that's where we're going to start off our notes today, talking about some physical, some chemical changes. Now, physical properties and physical changes. Physical properties are characteristics that can be observed without changing the identity of the substance. Okay? Without changing the identity. So, something that's like a phase change. I have a cube of ice. I sit it right here, a nice little cube of ice. I let it sit on the tabletop. What's eventually going to happen to it? It's going to melt, right? Okay, so that changed, but you know what? It's still water in it. It's still H2O. If I freeze it, guess what? Still H2O. I can get the water. Okay? If I evaporate it, okay, I can still get that water back. It has not changed the identity. If I take a sheet of paper here, here's a little sheet of scrap paper I got up here. Okay, this is paper, right? I've changed it, haven't I? But it's still paper, right? That's a physical change. If I take it and I rip it now, I've changed it, but is that still paper? Yes. Those are physical changes. So if I cut something, okay, I got some kind of a gem. I've got a diamond. Okay, I've got a diamond, and the jeweler's going to cut it to put it into a setting for a ring. They can fancy it all up, but it's still a diamond, isn't it? That identity has not changed. That is a physical change. We are not changing the identity of that substance. Melting point, boiling point, we just talked about. Okay? So those physical properties deal with the physical changes. No change in the identity. Chemical properties, on the other hand. Chemical properties, on the other hand, these substances are transformed into different substances. So we do have a change in the identity. The ability of charcoal to burn. Anytime we are burning something, we have a change in our identity. So I take this piece of paper that I just ripped up and stuff. I take a lighter, I light it. Can I get that paper back? That paper is gone, isn't it? Okay, so I have changed the identity of that substance. So if I change the identity of the substance, it is a chemical change. Now, obviously, if I burn anything, if I have a campfire and I throw a log onto the campfire, is that changing the identity of that wood? Yeah, I can't get that wood back. So that would be a chemical change. When we deal with chemical change, okay, we deal with reactants and products. And this is some terminology stuff that you're going to need to know for the rest of the year. And it reads up there, reactants, and this little arrow right here means yields. So reactants yield products. The left side of the arrow are the reactants, the right side are the products. Here, we have a chemical equation that you probably have dealt with at one time or another, okay? I have 2 molecules of hydrogen react with 1 molecule of oxygen. Those are my reactants, and they yield 2 molecules of water. So that is the production of water right there. So the product here is water on the right side. The left side are the reactants. Now, as we talk about the periodic table, this was the second video that we discussed. As we talk about the periodic table, okay, we talked about vertical columns. What's vertical? What's vertical? Up and down. So vertical columns on our periodic table are what we call groups or families. Each group contains elements that have similar chemical properties. If you look on your periodic table that I told you to take out, I want you to find beryllium. Okay, element number 4, beryllium. Right below beryllium is magnesium. Below magnesium is calcium, strontium, barium, radium. You find that group right there? Eventually, we are going to name those the alkaline earth metals. Okay? These metals are all reactive metals. They all have 2 electrons on their outermost energy level. You will learn a lot more about valence electrons. You'll learn a lot more about this periodic table in the weeks to come. Like I said, this is just an introduction. Horizontal rows are what we call periods. Horizontals left to right. Horizontal is left to right. There are 7 periods on your periodic table. If you have the bigger one, the 7 periods are labeled right here. If you have the bigger periodic table. If you have the littler one, they are not labeled yet. You will probably be labeling them before too long. But left to right across the table are what we call periods. There are 7 periods on our periodic table. Down at the bottom, there are 2 rows. Okay, down at the bottom there are 2 rows. We put these rows down at the bottom just to condense our periodic table. If you find element number 57, okay, element number 57 is lanthanum, right? Lanthanum fits in there, and then 58 is right after that. So if we would put those in the periodic table on periods 6 and 7, it would make my table a lot longer. So we put those under the periodic table. And what we call these are the lanthanide and actinide series. If you look, we just said lanthanum is element number 57. Element number 89 is actinium, right? Okay, that's where they get their names, the lanthanide and actinide series. So be aware, they fit into the periodic table right there in between elements 57 and 72, 89 and 104 on your periodic table. Okay? Now the final thing we're going to discuss is types of elements. Types of elements. Whether we have metals, whether we have nonmetals, whether we have metalloids. Okay? I've even heard these metalloids back in the old day called semi-metals. Okay? Semi-metals. Now, You should be able to tell me what every element on that periodic table is. How do we distinguish whether something is a metal, a nonmetal, and a metalloid? How can we tell? Skylar? Metalloids are touching the stair steps, but you got to understand what touching the stair step is, right? If it's touching a point of the stair, is that good enough? No. Okay? It's not good enough. Are there exceptions? Yes, like aluminum. Aluminum is a metal, but it is touching the stair step. So there are exceptions. So the metalloids touch the stair step. What about metals and nonmetals? What about metals and nonmetals? Anyone? Anyone? You should have watched it yesterday, right? Yeah. Metals are on the left of the stair step. Metals are on the right. What about those two rows below? Where would they fit in? The lanthanide and actinide series. They would fit in metals, right? They go in between right at 57 and 89, right? It's on the left side. So if I'm looking at calcium right here, I'm looking at calcium. What type of an element is calcium? What type of an element? What type of an element is calcium? Oh, let's go with Ella. It is a metal. Excellent. What about carbon, Maggie? Carbon is a nonmetal. Excellent. What? Medina, what about polonium? It's a metalloid, right? It's a metalloid. It's touching the stair step. All right. Mitchell, what about uranium? It is a metal. Element number 92, uranium. It's in the actinide series. Okay, it is a metal. Silicon. Ella, silicon. What do you think? A metalloid. Okay, a metalloid. I just got some silicon out today for a lab that we're going to do tomorrow. Not you folks. We're going to do this lab. But this density one that the other class will be using silicon. We talked about aluminum, right? Right? Austin told us that that was the exception, and it is actually a metal. But it's touching the stair step. Okay. Argon. Argon, Claire. Not going to find it on that side. Argon is a nonmetal. Okay? That group, okay, group 18, you find that number on your periodic table? Group 18. Okay? That group's what we call the noble gases. They are some of the least reactive elements that we have. And we'll learn more about them. Okay? Trenton, what about iron? Iron is a metal. Okay? Iron is a metal. Do you think we understand how to determine metals, nonmetals, metalloids? Okay? A little bit important. We okay with that? Good. Now,